So we're on the part 2 ng ating finance. So ito na yung last topic natin for our course. So introduction to digital logic, CAD tools or CAD tools, and VHDL. So sabi natin, ang logic circuits ay composed of logic gates, no? Yung mga previously mga pinag-aralan natin na connections, no? So we're going to discuss now about CAD, or ang ibig sabihin nito is computer aided design, no? So yung logic gates, napag-aralan na natin kung paano yung connection binubuo, paano yung mga logical circuits na nasa loob niya. For our part 2 at final topic natin, we're going to discuss paano siya dinidesign step by step. Okay? At ang isang tool natin or ng mga computer engineer, no, sa pagdi-design ng chips, no, ng isang computer or ng isang digital device ay yung CAD system, no, yung computer aided design system, which is usually includes the following: design entry, synthesis, okay, synthesis and optimization, simulation, physical design. Okay, so ito yung apat na to ang didiscusin natin. So let's go with design entry. So ang definition nito is design entry is the process of entering into the CAD system a description of a circuit being designed. So ibig sabihin, ito daw yung process of entering the description. Description pa lang yung ating nilalagay, no? So 3 common design entry methods. We can use the truth tables. The user enters a truth table in plain text format or draws a waveform that represents the desired functional behavior. Okay, so may dalang way yung user. May dalawang way tayo para mag-state or gumamit ng truth tables o maglagay ng truth tables sa description ng ating CAD system. We can use the text format daw or we can use the waveform. Okay, mamaya papakita natin kung ano yung waveform, no? Next, we can use the under ng design entry, we can use this schematic capture. User graphically enters a desired logic circuit. Na-discuss na rin natin to at may mga drawing tayo, no? Yung schematic diagram. May pinakita ko sa inyo mga example nito. Okay? So yun, no? Yun yung part ng schematic capture. So ilalagay natin yung ating drawing, graphical representation, at ilalagay natin as a design entry, no? Next, we have the hardware description languages. So ito hindi pa natin na-discuss, no? Ito lang truth tables and schematic diagram or schematic capture. Pag sinabing hardware description languages, ito yung HDL, no? User enters a programming language like description of a desired logic circuit. Pag sinabing programming language like, ibig sabihin para siyang program, no? Pero description lang siya. Okay? Ibig sabihin nun, hindi temporarily hindi pa siya iraran, no? Ilalagay lang natin yung description ng code. Okay? So yun yung ibig sabihin nun, hindi pa siya runnable, no? Next, after ng design entry, we'll go with first with the truth tables, no, using inserting design entry using truth tables. Yeah. So commonly used as a truth table is the waveform editor, no, to enter a timing diagram that describes a desired functionality for a logical circuit. So ito yung wave editor or waveform, no, pag ginamit natin yung paglalagay ng truth tables. Pwede kasi, di ba, remember, truth tables, pwedeng description, pwedeng waveform. Okay? So, ang example na to is waveform. Ayan, waveform. So, gagamit ka ng waveform editor, no, which is included dun sa CAD system. So, the CAD system transforms this into equivalent logic gates not appropriate for logic gates. So, ito yung disadvantage. Hindi siya pwedeng gamitin sa mga larger circuits, no? Smaller circuits lang ang pwede natin gamitin as representation ng design entry, no? Using waveform. So, but can be used for small logic function that is to be part of a larger circuit. So, pag nagdi-design larger circuit. Yung larger circuit na yan, pwede nating i-break, no? I-break down into smaller logic circuit. Okay? So kung yun ang ating design, pwede tayong gumamit ng waveform, no? Which can represent smaller circuits, no? So kaya sinabing waveform to makikita nyo, di ba? Yung taas baba niyan, yun yung wave. Okay, which is merong value yan, katulad nito. Pag tumaas siya, magiging 1. Pag mababa, ito 0. Okay? Usually, yung mababang wave, nasa babang wave ay 0. Yung nataas ay 1. Nasa taas 1. Kung halimbawa, katulad nito, dalawa yung may column dito, dalawang column, ibig sabihin yan 0, 0. So, hindi nagbago yung kanyang binary value. Okay? So, 0, 0. So, flat pa rin siya. Pero pagdating kay third column, siya ay 1 na. So, 0, 0, 1. Ito, 1 pa rin. Hindi nagbago. Bumaba, 0 uli, 0. So, that's how a waveform represents a 1 and 0 or binary Boolean logic connections. Okay? So, ito yung combination. Combination. Yung F, siyempre, yun yung sinasabi nating function. Okay? Ito mga input to. Input, ito combination. Next, we have the schematic capture. Okay? A common type of CAD tool. Ito yung malimit daw gamitin. No? The schematic refers to a diagram of a circuit in which circuit elements, logic gates are shown as graphical symbols and connections between them are drawn as lines. Natin ito kasi marami akong schematic diagram na binigay sa inyo as an example. Tool provides a collection of symbols that represent gates of various types with different inputs and outputs. So meron siyang tinatawag na library, no? So it provides a collection of symbols. So yung bumubuo, yung mga symbols na bumubuo sa schematic diagram, inipon niya yun sa isang file, no? Para gawing library. So kung meron kang hinahanap na symbols na gusto mong gamitin sa schematic diagram, dito mo siya makikita sa library. Previously designed circuits can be represented with a graphical symbol in larger circuits, known as the hierarchical design, and provides a way of dealing with complexities of large circuits. Okay, so sa library na to, nandun din yung ating mga previously designed circuits, no? Nandun yung mga symbol, no, na ginamit natin for the larger circuits. So ito yung example ng schematic diagram. Diba ito yung ating ganito yung types ng mga schematic example, no, na pinakita ko sa inyo. Okay? So itong F, lagi yung tatandaan, ito yung output. Okay? Kaya nga kanina nakalagay doon combination. So ito na yung yung result, no, yung result ng combination nitong tatlong input. Okay? So ito yung schematic diagram, ito yung waveform. Okay? So this schematic diagram represents this output, no, or waveform output. Next, we have the hardware description languages. Hardware description language, or HDL, is similar to a computer program except that it is used to describe hardware. So common HDLs are the following: VHDL, basic hardware description language, Verilog, and many others vendor specific. No? Pag sinabing vendor specific, nakadepende yon sa sa manufacturer, no, na nag-create ng hardware. Okay? So iba-iba yan ng HDL or ng hardware language. VHDL and Verilog are standards, offer portability across different CAD tools and different types of programmable chips. So although meron tayong vendor specific, itong dalawa daw nito is very common at saka very standards, no? So ibig sabihin nito, mas maraming manufacturer ang gumagamit ng VHDL and Verilog, no? Compared dito sa other types. Synthesis. So synthesis CAD tools perform. So nasa second na tayo, no? Second step. Kanina design entry. Then next is the synthesis. So synthesis CAD tools perform the process of generating a logic circuit from some stated functional behavior. So ano daw ang ibig sabihin? So it is a process of generating. So from the design entry, si CAD tools magja-generate ng logic circuit from the stated functional behavior base dun sa pinakita natin o binigay natin na waveform or truth tables or schematic capture na provide natin. Translating, under ng synthesis we have translating or compiling. So yung ating once na okay na, runnable na yung ating HDL, okay? Yan, pwede natin siyang i-translate or i-compile into a network of logic gates is a part of synthesis. So, translating or compiling is the next step, or part of the synthesis. Not only will the CAD tool produce a logic circuit, but it can also optimize that circuit in terms of speed and or size, logic optimization, called synthesis or logic optimization. So, kapag yung circuit ay pwede nating i-optimize daw, ang tawag doon ay logic synthesis or logic optimization. Finally, technology mapping and layout synthesis. So, sa third step ng synthesis, we have technology mapping and layout synthesis, which means which pertains to the physical design or complete the synthesis process. So after ng design entry, after ng synthesis, we have the simulation. Now, once designed, it is necessary to verify that the design circuit functions as expected. In a functional simulation, the user specifies valuations of the circuit's inputs and the CAD tool generates the outputs, commonly in the form of a timing diagram. So ito yung output ng CAD tool. Once na gamitin natin yung simulation, ibig sabihin ng specifies valuations, magkikreate tayo ng mga values, assumed values, doon sa ating circuit na dinesign para malaman natin kung tama ba ang output or yung output is what we expected. The user verifies generated outputs against the expected outputs. Next, functional simulators assume the time needed for signals to propagate through the logic gates is negligible. So sa under down ng functional simulators, ina-assume niya na yung oras kailangan para sa propagation ng signals or creation ng signals ay negligible. Ibig sabihin maliit lang na bagay para dun sa yung logic gates. Yan ang kanyang assumption. So for a real implementation, ito yung reason why for a real implementation this is not sufficient, kasi meron siyang assumption, kung gagamitin mo tong functional simulation ng CAD system, hindi siya accurate in terms of the real implementation, so ibig sabihin nito ay hindi ito accurate as basis for the efficient design ng iyong chips, ng iyong circuit. So, ibig sabihin kailangan mo pang ng much better simulation, ng further test, aside from the functional simulation. So, kung gusto natin, ito yon yung sinasabi kong aside from functional simulation, para makasigurado kang tama ang circuit, we can use the timing simulator to obtain an accurate and complete simulation. We are in determining the efficiency of the circuit. We use the functional simulation and also the timing simulator. Okay, we will now go to the introduction to VHDL, which is under pa rin to ng ng synthesis, yung compiling, compiling VHDL. Designer writes a logic circuit description in VHDL source code. Second, VHDL compiler translates this code into a logic circuit and representation of digital signals in VHDL. Logic signals in VHDL are represented as a data object, and VHDL includes a data type called bit and bit objects can assume only two values which are 0 and 1. Ito yung mga steps no involving sa creation ng VHDL. So yung VHDL, kine-create siya ng designer. Ini-input siya dun sa loob ng CAD system. So yung si CAD system, meron siyang VHDL compiler. Pag kinompile mo yung in-input mo na source code, the system or the CAD system will translate this code into a logic circuit. Siya na yung mag-create ng circuit mo. No? So writing simple VHDL code, example, first step in writing VHDL code is to declare the input and output signals, then done using a construct called an entity. Okay? So we create an entity. Sabihin ng done using is created no using a construct. Sa programming, di ba, sa Java, meron tayong lalo na sa C, no, meron tayong tinatawag na construct. Ibig sabihin ito yung, kasi sabi dito, nagki-create tayo ng object, no? The data is treated as object. So in order to contain the object, we should create also an object, and that is called the entity, no? Kapag nag-create ka ng maraming object or maraming instances ng isang object, you are using a construct. Name ng entity, yun yung name ng iyong circuit. Okay? So entity, example 1, is. Okay? Ito yung ating format, no? For declaring the entity. Yung example 1, yung parang variable name yan, tayo yung nagdi-define, no? And then yung port, sa load ng port command, we input the output and the input. No? Ayan. So output, input. So mga bit. So type. Okay? So makikita nyo rito ang declaration niya. Ito ay input. Yung result niya ay bit. Yung type niya ay bit. Okay? Type of the port. Mode of the port. Ito yung output. Ito yung mga inputs. Okay? And then, pagkatapos na mailagay, kung wala ng further command, further instruction, then we can terminate the procedure. Okay? So, end example 1. So, name of the entry, input, output signal ports defined. Dinidefine natin, ibig sabihin, dinideclare, terminate. So, yung diagram, ito, output, input. The entity specifies the inputs and outputs for a circuit but does not describe the circuit function. Circuit functionality is specified using VHDL construct called an architecture. Okay? So, yung functionality naman, yung kaninang ginawa natin is entity, yung object. No? Ito naman yung functionality kasi hindi nang dinidescribe yung circuit function. Ang ginagawa lang natin dito is kine-create natin yung entity or yung object. But, yung function niya, wala pa. Dito natin kine-create yun using the construct called architecture. Okay, so architecture, yung logic function niya, tayo nagpapangalan yan. Of, yun yung ating object, is, yan, begin. So dito na natin malalaman yung connection ng bawat port na to or bawat input, no? So itong output is greater than or less than or equal to. Ito yung pinakang logic natin. And then logic function. Okay? Kung mapapansin nyo, ito, walang logic function na command. Diba? Ayan. Logic, ito, walang or, walang and, walang not. No? Na command. Pero pagdating dito, yan, dito natin yung dinidefine kasi sa loob siya ng architecture dapat ilagay, no? Hindi dito sa entity. Okay? So ito yung example, complete VHDL code example. Meron din dito ang diagram. So entity, nag-declare muna tayo. Example 1 is ng mga variables tsaka port, input, output. And then we define the logic function. Okay? So logic function x1 and x2 or not x2, ito yon, x2 and x3 and logic. Okay? At ito yung output. Ayan. Ano yung OR? Ito yung OR. OR. But ano itong dalawang end? Ito, dalawang end. So ito, nagpe-pertain dito. Ito, nagpe-pertain dito. Si OR yung nasa gitna. At si input naman, X1. Yun. Okay. At si X2 and X3. Yan, ito, magka-connect. Okay. So from here, magka-connect siya. No? X2, X2. So by this example, may imagine nyo na kung kapag nabasa kayo ng logic function, command, alam nyo na kung paano i-connect, i-represent sa diagram. Boolean operators. The VHDL has built-in support for the following operators. And, logical and, or, logical or. Yan, ito daw yung mga operators na pwede nating gamitin, no? Sa loob ng VHDL. Assignment operator, we have less than or equal to a variable usually an output should be assigned the result of the logic expression on the right hand side of the operator. So laging si F, si output lagi nasa left side, and sa right hand side nandun yung logic output or logic function. VHDL does not assume any precedence of logic operator. So, ibig sabihin ng precedence, kahit anong mauna sa kanya, okay, wala siyang sinusunod na precedence. Okay? Kahit ano yung, ibig sabihin kahit ano yung unahin niyang i-evaluate, okay, ay magiging the same pa rin yung kanyang output. Use parentheses in expressions to determine precedence. Okay? So pag sinabing VHDL does not assume any precedence of logic operators, use parentheses in expressions to determine precedence. So kung mag-state kayo yung precedence, we can use the parentheses. Okay? Kasi kung di nyo lalagyan ng parentheses, yan, hindi siya mag-a-assume, no? Pagka wala kayong parentheses, kung ano yung nasa unahan, yun ang susundin niya. Okay? Sunod-sunod. Pero kung gusto nyo may precedence, kailangan mong gumamit ng parentheses para i-indicate kung sino yung dapat unahin at kung sino dapat yung huling i-evaluate. In VHDL, a logic expression is called a simple assignment statement. There are other types that will be introduced that are useful for more complex circuits. Okay, that's it for our part 2. So, see you on Sunday, and please prepare for a very short quiz.